Okay, number one. So what they're trying to get you to think about here, and as I said, the most obvious, or they kind of know what answer you're gonna like jump to. A common answer is a plus 2b plus 3, which I think was maybe a. That's a pretty common answer. So the problem is you don't know how to antiderive f of x because you don't know what f of x is. Like, okay, well, you can antiderive 3 though, right? That would be 3x. So you could work on that piece. So what you kind of need to do, or at least to show this out explicitly, I think it's easiest if you use the sum property and rewrite this as the integral of f of x dx plus the integral from a to b of 3 dx. Okay? And so this is a great example of the AP trying to test whether you can apply the sum property, whereas in a lot of examples you do the sum property, you don't even think about it, right? If it's a polynomial, if it's x squared plus 3x, and you're trying to integrate that, you're technically using the sum property, but you never write that out. And so, it's just, it's their way of kind of assessing that. So when I antiderive, or when I try to evaluate each integral, this one I know, right? This first piece here, this is a plus 2b. A plus 2b. This piece I'm going to have to actually figure out. So I'm going to antiderive 3. That would be 3x. Maybe we should put this in braces here. So that would be 3x. And then we're going to evaluate that from a to b. Okay. So we'll figure out what that area is. That's going to be a plus b, or 2b, plus, and this, to finish this out, it would be 3b minus 3a, so plus 3b minus 3a, and then combine like terms. So you end up with a minus 3a, that's negative 2a, and then 2b plus 3b, that's 5b, and hopefully that's what I said the answer was. What letter is that? C or something? D, as in dog? So on number 2, you're given, this is a Raymond sums, and they tell you, I should actually look at the question, Cresswell. They say, here's the expression, is a Raymond sum approximation for which integral is it an approximation for? And so you should first think of this as, all right, when you hear Raymond sums, think, okay, that's a sum of a bunch of rectangles. Rectangles, we find the area of those by width of the rectangle times the height of the rectangle, and sometimes we just factor out the width of the rectangle out in front of everything. Like the first one we did, it was like the width was, I don't know, 1 or 2 or something like that, and we saw that we were just rewriting it a bunch of times, so in the video I just factored that thing out in front. So when you look at this expression, you think, oh, okay, this is Raymond sums, and look, they factored the width of the rectangle out. Okay, so what does that mean? I have no idea what the curve is doing, but I do know that every subinterval is 1/20th of a unit long. Right? Okay, so again, I don't know exactly what the curve looks like. It doesn't matter, though. And then the question is, all right, well, these must be the heights of the curves, or the heights of the rectangle, right? And so then the question is, like, well, how did they compute that? Well, the way that you compute each height is by evaluating the function at each subinterval, right? So if you take, 1/20th, the height of this rectangle would be f of 1 over 20. So then it's like, all right, well, what is f of 1 over 20? They tell us. I mean, this has to be f of 1 over 20, right? So that has to be f of 1/20th right there. So they tell us that it's the square root of 1 over 20. And from this, we can reason our way back to what must the function be? That's a question for you. Yeah, it's got to be square root of x, right? It's got to be. So then we can figure out that f of x has to be equal to the square root of x. And then if that's the case, then since we've got all the rectangles listed out here, I know this ... is doing a lot of work, right? It's covering like 17 rectangles or something. But it does tell us how many subinterval, or how many rectangles there are. It also tells us on what interval we'd be integrating over. So clearly it has to start at 0, and it's going to go up to, 20 over 20. That's going to be the last, the end of the interval. That's 1. Okay, so if we kind of piecing this together, it's going to go from 0 to 1. And the function is going to be square root of x. And I think that's it. Should be, yeah, so it's b. And so this is a case where, honestly, I think the fact that it's multiple choice probably leads to more mistakes. Like a really common answer is C, where that 1/20th is out in front. I mean, you could see 3 of those answers have the 1/20th out in front, and that's just like, you see that and you're like, oh yeah, the 1/20th is out in front of the expression, it'd be out in front of the integral as well. So anyway, that's what's going on with that one. So in a lot of multiple choice questions, it's better to just look at the question, ignore the answers, do the thing, and see if you get the answer that's there. That's not always possible because sometimes you don't know what to do with the question, so then you try to kind of reverse engineer it from the answers, but you should always start with that. Okay, where's my cursor? There we go. Number 3 is the most commonly right, the most common right. The problem that most people get right, if they get one right. So you're trying to figure out what k value makes this integral 0. It's when k is equal to 2, and that is c. And that's because the integral from 2 to 2 is 0, and because it's that a to a property. There's no area when the bounds are the same. Okay, questions on 3? Fantastic. All right, let's dig into number 4. Number 4 is a really clever, wonderful problem. So they give you the second derivative is 6x plus 12. They also tell you that the tangent line at the point 0, negative 5 is 4x minus y. So you can see they've already made it clear that they're going to be obnoxious. They've put this in standard form of a line as opposed to slope-intercept form, despite the fact that it's basically useless. That's an overstatement. But slope-intercept is what we're accustomed to and usually where our lines end up. So anyway, they're already sort of trying to annoy us. But let's see if we can figure out what the answer to part A is. It says, find f of x if the graph of f is tangent to that line at the point 0, negative 5, given the second derivative. Okay, so most students can go, all right, well, I know I need to antiderive, right, because I've got the second derivative in front of me. It'd be cool if I had the first one. If I had the first one, I could get back to the original. That'd be pretty awesome. Then I could probably answer the question. So most students will go like this. So they'll try to integrate from, or antiderive 6x plus 12 with respect to x. And so then you get this. You get, so add 1 to the power, you would get 2. So you get 3x squared plus 12x plus c, some constant out there. It's like, okay, well, I got to figure out c. And usually this is where students get stuck. So sometimes students will kind of try to blow through it, and they'll just be like, oh, I'll antiderive that and try to deal with the c later, especially because they have this, what's called an initial condition. They have this point on the line, or the curve, which is 0, negative 5. We do have what we need to figure out c at this point, though. So given the tangent line here, actually back up a second. If I knew what the derivative was, I should actually write that this is f prime of x here, right? So if I knew what the derivative was, like if I knew that, for instance, the derivative at 7 was 20, I could plug in 7 here and 20 here and solve for c, right? Then I'd only have one variable to solve for. So it's like, well, if I knew what the derivative was at a point, I could solve for c. And it turns out that we do. We do have that information. It's just sort of encoded in the fact that this is the tangent line here. So if I solve this for y, I'd add y to the other side, and then I would subtract 5. So I get y is equal to 4x minus 5. This turns out to be f prime of 0. Right? F prime of 0 is equal to 4 because that's the tangent line at 0, negative 5. So the slope of that tangent line is 4. That's the derivative. Okay? So I know that 0, 4 is on the derivative. So I can write this. 4 is equal to 3 times 0 squared plus 12 times 0 plus c. All that stuff goes away. I get c equals 4. Right? Questions? Yeah. Okay, let's talk about points real quick. So at this point, well, actually, we should write this down. F of x is equal to 3x squared plus 12x plus 4. Okay, so as far as point breakdown, now I sort of improvised on this just based on what I knew about the AP test and how they might assign points. I think you're going to get a point for this expression here.
Wait a minute, isn't that f prime of x?
Yes, thank you. I'm sorry. Yeah, we're not done, are we? F prime of x. Thank you, thank you, thank you. Okay, so you're going to get a point here for doing the antiderivative plus c correctly. And I think you would get a point for showing the reasoning that your c value, the reasoning to get.
C value is wrong, but you still showed the work.
Yeah, that's a good question. So I'll answer that in just a second. So you get a point for getting the c value right, and then a point for actually writing the derivative out. Since it's a free response question, you're going to want to write this stuff out clearly in your work when you actually take the test, so that whoever's grading it can actually track through your thinking and make sure that you've got the correct components and can give you points. So then we're going to take and antiderive this. So a little dotted line here. So we're going to take 3x squared plus 12x plus 4 dx. We're going to antiderive that. So we will get, this will be the original function. We'll get x cubed plus 6x squared plus 4x plus, I'm just going to use k so we don't get confused as to so that we don't confuse the constants by calling them both c. All right, and then we know that this function goes through the point 0, negative 5, so I can plug in negative 5 for the function, and 0 plus 0 plus 0 plus k, so therefore k has to equal negative 5. And so to sum up on that piece, we have our final answer for A. F of x is equal to x cubed plus 6x squared plus 4x minus 5.
What if we have the k value right and the c value wrong?
All right, 1 second. Let me kind of sketch out the points here. So I think you would get a point for this here. I think you get a point for the reasoning on the k, and I think you get a point for summarizing it and writing the function correctly. Okay, so. And so we're trying to find the average value, and this is again a spot where I think if your function was wrong, but you figure out the average value correctly for your function, you're still going to get the points. So the average value is going to be 1 over b minus a, and it tells us in the problem we're looking what, from negative 1 to 1 or something? Yeah, from negative 1 to 1. So it's going to be 1 over b minus a, so that's 1 minus a negative 1, so 1 plus 1. The integral from negative 1 to 1 of the function, which was x cubed plus 6x squared plus 4x minus 5, all with respect to x. And this is why I've said that in that section that we just did, section 3 I think it was, that when it says, when the problems are grayed out, you want to be doing those by hand so that when you come across something like this, it's sort of automatic. All right, so we'll have the 1/2 out in front. I'm going to antiderive everything. So I'll have 1/4 x to the 4th plus 2x to the 3rd plus 2x squared minus 5x. That's all evaluated from negative 1 to 1. I'm going to plug in the 1 and plug in the negative 1, so I get this. The average value is equal to 1/2. We got to be careful here. I'm going to plug in 1, so I will get 1/4 plus 2 minus 5 minus, plugging in negative 1 now, I still get 1/4 minus 2 plus 2 plus 5. Check me. Does that look right?
Sure. Wait, why? I thought this made it wrong.
Okay. And so then, finishing this out, you get 1/2 times, so I have a 4th minus a 4th, so those are gone. I have 2 minus a negative 2, so that's going to be 4. Well, actually, you know what? Is that the best way to do that? I guess I already committed. 2 minus a negative 2, that's going to be 4. I've got 2. You should not do it like this, Cresswell. You should not do it like this. 1/4 plus 2 is 2 1/4 plus 2 is 4 1/4 minus 5. Is that negative 3/4? Okay. minus a fourth minus 2, that's negative 1 3/4 plus 2, that's positive 1/4 plus 5, 5 1/4. I'm not sure that way was much better, but let's see if I end up getting it right. So I get 1/2, and then negative 3/4 minus 5/4, that's negative 6. Yeah, I did get it right. And so that's going to be negative 3. But doing all those problems that that they said, oh my gosh, right to the end of the hour. All right, well, that wraps it up. Have a fantastic day. I'll post this video later.